Hello, hello, welcome back. It looks like we lost a few people with a beer, but if you're here, you really care about anomaly detection and cloud as well. So I want to get started with a question before we get into the topic. So has it ever happened to you that you look into your product or your service or whatever you're building in Java or not in Java, and something is wrong and you have no idea why? Ever happened to you? I'm sure it did. Come on. Okay, don't be shy. Cool. Usually when it happens, it's because something happened in a place that you have no idea where it is. It could be on the mobile side or depending on what you're building, that is out of your visibility, out of your control, but there are still ways to detect those issues, those problems, those data drifts, whatever it is. So in this session, I want to show you a couple of ways that you can figure out what is going on and why. And if you never used or heard of anomaly detection, that's just a technique that helps you solve that problem. You identify anomalies and you try to analyze and figure out what is the cause of the anomaly so you can fix the problem. So as simple as that. Sorry, it's not Java-based, what I'm going to show you, but it's very related to the business problems and the situations that you are encountering. I'm Alex. I'm a developer advocate. I work for AWS, Amazon Web Service. How many of you know AWS? Oh, nice. Cool. I don't have to give you a 30-second course on AWS, and that's not what I'm going to do today. I'm a software engineer. I love doing web development. I used to work a bit with Java. Now I mostly use, can I say JavaScript here? Yeah. And Python. Can I say Python? Okay. But I love programming. I'm a web developer, and I work in a startup. How many of you work in a startup? This is the last question, I promise. Okay, a few startuppers. Before we get started, I have a couple of reminders and shameless plugs, and things that I do and things that maybe you are interested in. I also met a few people in the audience who already know this. It's a podcast in Italian. I think that many of you speak Italian, if not most of you. So if you're interested in the cloud in general and interviews and deep dives and all sort of things, I host this very popular podcast in Italian about AWS. And the second shameless plug, because we are in Switzerland, there is a AWS region coming to Switzerland in the next year and a half. So just so maybe you didn't hear about it, I think it's a good reminder. So let's get into the topic after the shameless plugs. I had to do the shameless plug. So what is officially an anomaly detection, or what does it mean? What does it solve? This is from Wikipedia, because we like official definitions, right? So the idea is to find and identify rare occurrences or rare data points or items in a data set around the observations that are very different or slightly different, and it kind of depends on the severity, from the norm or from the majority of the data. That's how you are able to identify those anomalies. And there are many examples of anomalies, but before we get into the examples, I want to give you a much simpler definition because we like to be concise and business focused. So if you have outliers or problems or issues in the data and you have no idea why, there is a good chance you can benefit from using anomaly detection, and that's why we're here. It's quite likely that you'd find this useful in your career or in the next few years. Maybe you need it today, and what I hope from this session is that tomorrow or next week you'll be able to apply this in practice. So let's move forward. Oh, there is an asterisk, because many people that I talk to, especially developers, think that finding the anomaly is the result of anomaly detection. In practice, that's just the first step. Detecting the anomaly is just the first step. Then you want to go and look at the root causes and go and fix the causes that cause the anomaly, right? And that is why we are here, okay? Anomaly detection is a tool. And if you think about most tools that you use today, the more tools you have in your toolbox, the better you can solve problems, whether it's a technical problem or a business problem. So we are here to extend our toolbox with something new that we can use. So what kind of anomalies do we meet every day in our data, in our business, in our technology stack, for example? I wanted to give you a couple of examples. One is related to data. Imagine you have, I don't know, this could be revenues in your e-commerce, okay? And there is a clear pattern, you know, because people don't usually buy at 3 a.m. in the morning, so there is seasonality. And usually it's fairly easy to identify if something is really wrong. If you can see, you know, these missing values here, something definitely went wrong. And it could be that the website went down. It could be that the reporting system went down, so everything's fine in the product. There are many potential root causes, right? But it's not only about these kind of time series data. You know what's a time series is just a series of data points that kind of change every minute, every second, every hour. So this could be the CPU percentage of your virtual machines, or this could be any kind of time series data or information. If you think about what you're doing every day, think about a time series that applies to your business, to your code that you're writing. There is probably some kind of data set that looks like this and that might expose some kind of anomaly. But it's not only data sets like numbers and strings, it's also multimedia. If you are building something, I don't know, for manufacturing, how many people have implemented systems that look at, I don't know, a manufacturing product line that is producing items and real products, and maybe you want to identify defects in those products, because you can take a picture of it and see if there is a scratch and see if there is something. And this is super useful because if you are a production company, you don't want these defects to go all the way downstream to your customers. You don't want to sell a car that have a huge scratch on it, right? If you are producing cars. And the same applies to a lot of other use cases. So using anomaly detection on multimedia, which could mean pictures, but it could mean audio, it could mean, you know, other sort of multimedia sources, is also applied today in the industry. And I think as a developer, as an architect, whatever you're doing, it's really important to understand how to use this kind of technology to help the business, because our job as developers is to help the business fix the technical side of the problem, right? Let's not forget that. Now, if you're interested in solving that problem, maybe you have a use case in mind right now for your company, for your business, you could go on and study statistics and engineering and data science and spend the next couple of years at university and graduate and be happy about it. That's what I did. And many people, maybe many of you did the same. But if you don't have that background, if you don't want to invest the next 6 months or 12 months or 24 months on that, well, maybe you have a problem that you can solve this week or this month or this year, because that's what business usually looks like, right? You don't say, sure, let me go to university for a couple of years, I'll be back and fix your problem. You can't do that in business. So what you could do, and that's why I'm here today, you can use APIs. We just talked about APIs for an hour. Sorry, this joke makes sense only if you speak Italian. So APIs are bees in Italian. Bees are APIs in Italian. We talk about Java APIs. There are also a lot of other APIs like web APIs and cloud APIs. What is the cloud? It's a set of APIs that you can use to do stuff. So I work for a cloud company, so I'm a bit biased, and today I'll show you the AWS cloud. But what I'm talking about applies to a lot of other technologies and vendors and problems that you can solve exactly the same way. So what APIs can we use to solve this specific anomaly detection problem? So today there are like 200 plus services on AWS, and there are 2 of those 200, by the way, that solve exactly this anomaly detection problem. So that is what I'm going to show you today. What I want to take away from this presentation is not, please use AWS. What I want to take you from the presentation is there are APIs that you can use to solve problems without going 2 years at university, and you can solve those problems today with the data and the technology that you're using today. You're programming in Java, you can use the Java SDK to do all of this that I'm showing you today. So what services I'm talking about? Again, in this slide, there are only the artificial intelligence services, and there are, this is one, but there are like 3 or 4 that are specific to anomaly detection problems like the ones that we just talked about. There is a lot more. There is text-to-speech, speech-to-text, natural language understanding, image analysis. You know, there is another 20 services that we are not talking about today, but I wanted to give you the picture of what exists, again, with the mindset of let's extend your toolbox with more tools that you can use. That's the way a lot of companies build software systems today. If there is a tool that I can use, a microservice that I can use, I will build my microservice, and then I will integrate my microservices with maybe existing microservices that the cloud provider is offering me. You don't have to, but often it's a good way to go to market faster. Now, the 2 services I want to talk about today are, system errors, are lookout for vision and lookout for metrics. These are 2 lookout, like there is a lookout family of services that help you with anomaly detection. And I want to show you the vision one is super interesting because you can just throw images at it. You say these are normal images, these are anomalies, and the service will automatically learn the context and the business context, and with as few as like 30 or 40 images. Okay, if you're doing your own deep learning model to do this kind of stuff, sometimes you need hundreds or thousands of images. So I think it's a good way to get started. Now, I don't like PowerPoint, so let me do a demo. I think it's more practical. Now, let's look for a data set that allows me to showcase this. I found this data set from 2017. This was like state-of-the-art issues, how to find scratches and anomalies. This is a data set of like industrial patterns, okay? There are hundreds and hundreds of images, I think thousands of images, where they tell you this is normal, this is an anomaly, without circling the anomaly. Okay, this is just to understand. There is a little scratch here, there's a little blur here. There are, actually, let me zoom in. There are 6 different classes of anomalies, and I'm going to pick one because it's, you know, let's focus on one. I think the one I picked is this, where you have like a almost white noise kind of background. This is a very zoomed in picture of an industrial pattern, like a material. And sometimes there are scratches on it, okay? Let me show you what you can do with this. You download the data set. It's already split between anomalies and not anomalies, so you start from something. If you have your own data set, you can do the same. It's quite likely that you have an idea in your images what is anomaly and what is not anomaly. Let me show you the service itself. The UI is not super important. You can do the same with APIs. Java APIs or Python APIs or JavaScript APIs, it's the same. There are tens of SDKs. So all you do is you create a new, what's the name of it? You create a new project. Inside a project, you create a data set, and then inside that project, you train a model. Now, I already did that because it takes 2 hours, and I only have 15 minutes left. So I need to show you something that already works. Now, let me take a data set, a project that I already created. I don't know if you can see the anomalies in that projector, but these are normal images, just normal. Human eye can detect it pretty well. These are anomalies. Can you see the scratch here? Yeah? Okay, that's, in that business context, an anomaly. It's a problem. It's a product that I don't want to go down the production line. I want to stop it, fix it if it's fixable, or go and recycle and do whatever I want to do. Now, this is the interface. You can do the same with the APIs. And I can do the categorization directly here in the interface if you don't already have that information in your file system structure or whatever database you're using. After doing that, you just click on train model, and that's the auto magic happening. We wait an hour or two, depending on how many images. Here, I uploaded like 1,000 images, so it took a couple of hours. If you have 50, it might take 10 minutes, okay? Then you end up with a model. You don't need to be a machine learning expert. Here, a model is just a smart algorithm that worked on the data and now has learned how to identify these images for you, okay? It's just a smart black box for you. We talked about AI a couple of hours ago. This is exactly it. You enter that model, and what is surprising for a lot of people is that we get 100% accuracy on this kind of model. So in 2007, this was state-of-the-art problem that it was hard to solve. Fast forward 14 years, now in an hour, for like $1, I can solve that problem with a managed service that doesn't require me to be a PhD in data science, okay? 100% accuracy is not very common in AI problems. It's more likely that you get a 92%, 95%. You want to get as close as possible. It's okay to have some false positives or false negatives. It's still much, much better than not having anything, right? Now, what's interesting is that now from here, I can go and click Use Model, and I get snippets that I can use. So there is an API to start the model, to say, start this project, this version, because you can have multiple versions, how many virtual machines under the hood you want to have. So it's not completely serverless, permits me to use that term. But you still have some control of the underlying infrastructure. Then what you actually use, and again, this is using the CLI, you can do exactly the same with Java, Python, .NET, whatever language, is look out, detect anomalies with this project, with this model, with this image type or content type, and then you just provide an image. You call that API, you get back a Boolean value, true, false, with a confidence in percentage. So that's an API. You don't really care. You don't even want to know what's behind it. We take care of that. So super powerful. Do not forget to stop the model, okay? It has an hourly cost. That is how a lot of cloud services are built. You are charged for. There are other services that are charged on a consumption base. So if you do 10 API calls, you pay for 10. If you do 100, you pay for 100. Some of these services do not have that. In particular, Lookout from Vision is charged by the hour, even if you don't use it. So be mindful of stopping and starting only when you need it, okay? In a production world, maybe you need this 8 hours a day, so you use it 8 hours a day. If you only need it for 1 hour, you pay for an hour. That's how the pay-as-you-go model works. Now, that's it. It's simple, okay? So if you have a data set, go and give it a try. It's pretty easy to use. You don't always get 100% accuracy, but that is fine. If you don't get a good accuracy, add more images, or maybe check if you have correctly classified the images, and hope for the best. If this doesn't work, there are other ways, right? You can use Amazon recognition, you can build your own machine learning model, but again, that kind of requires you to be a machine learning expert, or at least like a data science or a data engineer or something a bit more in depth. Now, there is an interesting script that I want to share with you if you are interested and want to see what the full API looks like. You can find an example here. If you're curious, I can share more examples too. Now, let's look into the other case, which I believe personally is even more interesting, because maybe not everyone works with images or pictures of a production line or whatever other image, but almost all of us, all of you, all of programmers work with data. If you are a programmer and never work with data, you're building something very specific, and let me know what you're building. I'm curious. So look out for metrics. Exactly the same approach, but you can work with data and time series data in particular. So you provide a few hundred or thousands or even more data points. You will go for looking for the patterns and the seasonality, and there are like tens of connectors. If your data is a MySQL database or on Amazon S3 or on all sort of data sources, it's quite likely that Lookout for metrics can connect to it. And again, I hate PowerPoint, so let me go back to to the browser. Now, yeah, by the way, this was the script that I wanted to share with you. It's just a little bash script that shows you how to split the files and do everything I showed you in the console with a bash. You can do the same in other languages. So let me clean up a little bit. Now, look out for metrics. I have a data set that I want to share with you. Let me take it. Yeah, so it's an e-commerce data set just to make things simple and so everybody can understand what kind of simple data set we're working on. Let me zoom in. So this is our data set. We have one data point every hour for different platforms like web and mobile, for different countries like US, UK, Germany, France, Italy, and so on. The timestamp. We have two dimensions. We have the views and we have the revenues. So how many people view the page or the e-commerce, and how many orders were fulfilled. So how many revenues, how much money was spent on the e-commerce. So this is what the data looks like. What we want to identify is if there is any anomaly in the number of page views, because it might mean the website is down or something is wrong with the network and blah, blah, blah. Or if there is an anomaly with the revenue, because maybe something is wrong with the payment system or with the payment gateway or with something else. So this is important. This has a clear impact on the business. And as a developer, I think if something is wrong here, you want to be able to identify it, go and fix the technical problem if it's a technical problem. So let me show you how you would go and create a detector. So again, I'm doing it in the console just because it's more visual and easy to follow. Yeah, my detector. Cool. Now you can specify how often you get new data, because this is interesting. With images, we saw a static data set, right? You have historical data set and you can look for anomalies there. But often you have continuous data coming from a system. It could be an IoT system, a domotic system, an e-commerce, or something that keeps sending you data, right? And you want to potentially identify issues and anomalies as soon as they arrive, not 2 weeks later, right? It's more interesting if you can do it continuously. And lookout for metrics allows you to say, I have an historical data set, look for anomalies there, or I have a continuous data set that I keep updating every 5 minutes, every 10 minutes, every hour, or every day. And that's, I think, is super powerful. So my data set is hourly, and I go and create it. Now, next step is to add a data set. Pretty simple, my data set. Now here, besides the time zone and all the optional stuff, I can pick my data from all sort of data sources. Like I mentioned, there are a lot of third-party integrations. You have stuff in Google Analytics or in Zendesk for customer support, or in Salesforce for sort of CRMs, or I don't know, in your Postgre, MySQL, MariaDB, all sort of databases. I will show you S3 because it's quite likely that if you have a data pipeline, your data, your historical or live data will end up in Amazon S3. And I already have a bucket, but my memory is terrible, so I copy and paste the location. Cool. So in this bucket, I have a big CSV file. I have a big CSV file with exactly the same structure I showed you. I think it's like 3 or 4 megabytes of data. It's CSV. I can go and configure all the structure. And when I click next, so the service has already validated my data, and I can say, and I can do some mapping. So what are the measures and what are the dimensions? Measures is the stuff that I want to find anomalies in. So the views and the revenues. So I can go and do the mapping. See, the service already figured out what are my fields. I can also see and pick the aggregation, because if it's like a CPU average, it's probably an average, and I don't care about the sum. In this case, we care about the sum of the views and the sum of the revenue. Dimensions are all those dimensions that would be useful to identify what's the root cause. Because let's not forget, finding an anomaly is the first step. Then, I don't know, revenues goes down 25% from out of nowhere. what is the problem? Where is the problem? What's the platform? What's the marketplace? What's the time of the day? You know, I want to be able to go and identify the correlation between those dimensions, right? And then I pick the timestamp, and I've done all my mapping. Now here, I review it. I can save and activate this detector, meaning it will now start the training. Similar to what we did before, this would take an hour or so. So let me skip straight into the pre-trained model. Now, what I find here, once the model, too many requests. I don't think I'm doing too many requests. Okay, cool. What I find here, the model is trained. It's likely has found a few anomalies. This is super useful. If you ever work with anomaly detection, usually you have thresholds for individual parameters. Like say you have 10 dimensions, like page views and revenues and 8 more. Usually you want to identify those thresholds or severity scores for each individual dimension, and you know that's like impossible in most cases. So what Lookout for Metrics does for you is to automatically create a unique severity score across all your metrics. So you don't have to deal with 200 severity scores. So you pick one, and then you can filter, I don't know, anomalies above 83. I'll go and pick the very important anomalies. Here I have a list. Of course, I'm using a synthetic data set that allows me to show you a few anomalies. So say that I sort them by severity, because I'm likely more interested first in the very impactful and severe anomalies. I already selected a few, so I can show you what happened. Say that I click on revenue impacted on December 19th of last year. I click there. What I can do here is that famous root cause analysis that we mentioned a couple of times. So what's happening? Pretty severe anomaly. Last year, December 21st, revenues are impacted. The correlation with my dimensions are 100% from the UK and 100% from mobile. This already gives me an interesting idea where the problem might be. Maybe it was a network connectivity issues in the UK. Maybe my mobile application had a bug, and I went and fixed it. Now, this is from almost a year ago. It's probably already fixed. But if this was happening right now, because I set up continuous monitoring, I may want to go and investigate and see what's going on. Can I reproduce this? Can I find an error? Do I get any error message from my iOS code or Android code? And this is where the root cause analysis and investigation starts. If you don't have this, it's kind of hard to go and figure out the problem. And maybe if you look at the aggregated data, you don't even find that a small percentage of the revenue from the UK, only from the mobile app, is going wrong. So even not just that, I also get a visual way to figure out what's going on. What is the anomaly about? So this is the pattern in the hours before the anomaly. And this is what happened. Like, I was expecting something here, and it just went down to 0. This is definitely something I want to go and investigate and fix, because the revenue are going to 0 from 1 hour to the next one. Is this relevant? Yes. Please keep telling me if stuff like this happens. If this wasn't relevant, I could just say no. Like, if the revenues went up, awesome. But I don't care. Like, don't send me an email to tell me that there is too much revenue. There's never too much revenue, right? Let me show you another example. In this case, views are impacted 100% from friends, 100% from the mobile application. So it could be a similar issue as before. Similar case. So something went wrong and just dropped abruptly, and this is relevant. So I can give human feedback to the model that will improve over time. Let me give you another example. Here it's a bit more complex. I have some events from Germany, from Japan, from Spain, a little bit from mobile, a lot of them from web. But then I can go and dive deeper. So in the metrics graphs, I can see that in Japan, from the mobile application, the views just went down. So this is definitely a problem I want to go and investigate, and click on yes here. From Germany, mobile application, the views went up. Is this relevant? Maybe it is, but let's say that I don't care about things going up in this specific context. I care about things going down because I want to fix it. So I can say no. And same here, this was already kind of messed up. So is it relevant? Maybe not really. So I have a way to instruct the service about what I care about, what I don't care about. And the service gives me a way to investigate further and go and find and fix the actual problem, because the anomaly is not the problem. The anomaly is the consequence of a problem that, as engineers, we can go and fix. And that is it. It's actually fun to use. And if you have a data set, I highly encourage you to give it a try. There is the same data set that I've used. You can find it here together with some code and how to do exactly the same stuff with your Java SDK or whatever language or system you're using. And that is all. I hope I gave you guys an interesting or different way to think about anomaly detection, finding problems in data, whether it's images or metrics or time series data. And I hope it was useful. If you have any questions, I'm here. Thank you.
Grazie, Alex. Is there any question, maybe for Alex?
English or Italian?
Oh, one.
Fine.
Wait.
Posso parlare italiano?
Certo.
Ok. Questo software, Amazon Lookout for Metrics, questo API, può prendere in considerazione anche giorni speciali come, che so, il Natale, perché sappiamo che il Natale le revenue schizzano e voglio considerarlo diversamente.
Certo, allora il modo migliore... Ti rispondo in italiano. Ti rispondo in italiano. Il modo migliore per farlo in quel caso è già dargli dei dati storici che hanno una stagionalità. Quindi se hai 2 anni di dati, lui già vedrà che a Natale c'è quel picco e quindi non continuerà negli anni a dirti guarda che c'è un'anomalia il giorno di Natale. E poi dipende anche come glieli dai questi dati. Se gli dai il dato giornaliero è chiaro che quella diventa l'anomalia, se gli dai il dato orario ogni 10 o 5 minuti è chiaro che lui vede un pattern, una stagionalità diversa. Quindi il mio consiglio in realtà puoi anche fare il training di modelli con granularità diversa, che quindi andranno a verificare una stagionalità diversa. Dipende quanti dati storici hai. Se non hai dati storici puoi comunque iniziare a usarlo e dirgli guarda che io ogni 10 minuti ti butto i dati qua e lui ogni 10 minuti va a guardarli e inizia ad imparare i pattern. Mi pare che il servizio comunque abbia un minimo numero di campioni da cui partire. Se gli dai 10 data point è difficile trovare anomalie. Però sì, è sufficientemente intelligente da evitare di romperti le scatole il 26 dicembre tutti gli anni. C'è qualche altra domanda?
Quando hai mostrato la possibilità di visualizzare un'anomalia, quindi la possibilità di selezionare sì e no, nel caso in cui si seleziona il no, riparte il retrain del modello oppure semplicemente no, non mi interessa e quindi la prossima anomalia uguale a quella me la ripresenta?
Allora, decide lui quando fare il retraining, glielo puoi dire anche tu manualmente. Penso che quella cosa si vada ad applicare al prossimo retraining. Quindi se gli dici adesso, gli butti degli altri dati fra 10 minuti e c'ha lo stesso tipo di pattern, penso che subito, nell'immediato te lo ridica. Se vuoi davvero liberartene, puoi rinforzare un nuovo training e allora lui si aggiorna. Però quel tipo di meccanismo human in the loop viene chiamato, no? Cioè riesci a dirgli cosa ha senso o non ha senso per te, diciamo che ha senso nel medio termine, quindi se hai una stagionalità oraria allora sì, ti serve subito, ma di solito hai stagionalità settimanali o mensili o ancora di più, quindi è pensato per un utilizzo a medio-lungo anche.
Grazie.
Niente. Abbiamo tempo per un'altra? Sì.
Ciao, corta. Volevo sapere, nel primo esempio dell'API che bisogna tenerla sempre accesa, come mai? Non ce n'è una sola chiamata?
Non va tenuta sempre accesa, va tenuta accesa finché ti serve avere questo modello da poter invocare. se ti serve 1 ora al giorno, la tieni accesa 1 ora al giorno. È pensata così per questioni, penso, di capacità, perché dietro le quinte possibilmente vengono utilizzate GPU o istanze che una volta che le fai partire non le tiri su per 10 secondi, magari le tiri su per un po' di tempo. Infatti a partire ci mette 4, 5, 6 minuti, una volta che è partito lo usi e poi lo spegni. Penso sia una questione di capacity. E non è detto che rimarrà così per sempre, magari prima o poi diventa più serverless, però insomma vedremo cosa succede.
Abbiamo un'ultima domanda.
Sì.
Ciao Alex, scusa, una domanda sulla pattern recognition che tu hai fatto sulle immagini. Non imposti tu il validation, cioè come fa a sapere qual è il training set, il validation set? Perché una cosa che mi ha dato fastidio è di solito in machine learning tu non hai mai il 100%. Cioè il 100% di solito è sintomo di overfitting, o meglio detto, tu stai matchando esattamente i tuoi dati. Cioè quello che tu hai dato in pasto, l'algoritmo lo matcha 1 a 1, ma quando gli do in pasto una nuova immagine non funziona più.
Posso avere il proiettore? Te lo faccio vedere. Hai ragione, ed è vero, infatti quello che fa Lookout for Metrics, che è il secondo, è che gestisce lui, mi pare faccia un 70-30 di default, quindi usa il 70% dei dati per l'addestramento e poi fa un tentativo di prova per vedere se funziona sui dati restanti. Quello che ho fatto qua, e ho condiviso lo script per darvi un'idea, è fare io in questo caso, perché Lookout for Vision invece non fa quello split, gli devi dire tu, questo è il mio dataset composto da un training set e un testing set. Quell'operazione la fai tu via API o... perdonatemi. Io amo e odio PowerPoint allo stesso tempo. Qua, vedete che cosa faccio? Scarico il dataset. Sì, il dataset era formato da uno zippone con le immagini normali e uno zippone con i difetti, quindi le anomalie. Li unzippo, li butto tutti su S3, perché poi li referenzio su S3, e poi faccio 2 bei lupponi. Non so perché l'ho fatto con la CLI, potevo farlo con Java o con Python, che era più facile, però ho deciso di farlo con la CLI. E quindi, in modo casuale, prendo l'80% delle immagini sia giuste, cioè sia regolari che anomalie, e mi creo manualmente il testing set e il training set. In questo caso ho fatto un 80-20, penso che si sia raggiunto il 100% di accuracy semplicemente perché è effettivamente abbastanza evidente, non ci sono casi limite estremi, un po' no, edge case, per cui è difficile capire se è un'anomalia o no. Era un dataset abbastanza facile. Ci saranno altri dataset. Non credo sia overfitting comunque, per rispondere alla tua domanda.
Grazie mille.
Prego.
Grazie Giovanni.
Grazie a tutti di nuovo. Se avete altre domande vi aspetto qua.
Sì.